Yes.
Right. Good morning, good afternoon, good evening, depending on what part of the world you are in, guys. I just wanted to take a minute to introduce Rama ma'am. Being an ex-IBMer, I'm extremely excited that she's here amongst us today. Rama ma'am is an IBM fellow and a director at IBM Watson's division. She's also a master inventor and a member of IBM Academy of Technology. She's presently leading artificial intelligence operations mission at the Watson Group. She and her team have developed and released multiple AI services such as personality insights, tone analyzer, and emotion analytics at IBM Watson by employing psycholinguistic machine learning and NLP techniques. She has co-authored 6 book chapters and over 100 technical papers, has 25 plus patents, 20 plus pending patents. She's the recipient of 4 Best Paper Awards in the areas of AI operations, from reputed peer-reviewed conferences. She's also received multiple awards at IBM, including Best of IBM Award, 2 IBM Corporate Awards, and multiple outstanding technical achievement awards. She's been named top 20 women in AI research by Forbes in 17, a top 6 18 for AI by Fortune magazine in 2018, and top 10 pioneering women in AI and machine learning by Enterprise Management in April 2019. Ma'am, it's an honor to have you. I'll turn it right over to you so we can get started, and then we'll take up some questions from the audience.
Thank you very much, Parikshit, for that introduction. And thank you for the Data Science Congress conference for inviting me and having the opportunity to speak to this audience. So let's get right to it. Let me share my screen. Parikshit, host disabled attendee screen sharing. So I'm not able to share my screen. Can you enable that, please?
Tushant, can you check into that, please?
Yes. Sure.
I still get the same error.
I could see your screen until a couple of minutes ago.
2 minutes, 2 minutes, Parikshit, 2 minutes, 2 minutes.
So while we have these 2 minutes, ma'am, do you prefer the West Coast or the East Coast? I know IBM research remains the same, but coast area-wise, what do you prefer?
Well, you know, you can't beat California weather. It's great here, but I do miss the fall in in New York. New York has got spectacular fall colors.
Absolutely, yeah.
Yeah.
So when you were
The rights are given, Parikshit. Okay.
Excellent. All right, ma'am. Let's get to it.
Okay. All right. Share my screen.
Got it.
Can somebody acknowledge and tell me
if
you can see the screen? All right. Okay. So let's go. All right. So I thought I would tell you all about making AI work for enterprises. So what does it mean? Why am I specifically calling out AI work for enterprises? Why not just say putting AI to work? So I'll tell you why that is the case. And I'll take a methodology perspective today based on specific experience that I have of building AI models and applying AI to various kinds of problems. So the key takeaways I would say are the following. I would argue in this talk that enterprise AI is different and is more complex than consumer AI. And I would further argue that for enterprise AI to work, AI must be taught the language of the enterprise. It's not just the language of the humans, but also the language of the enterprise. So I'll tell you more about that. And I will spend much of my talk on this, the third topic, which is saying that for enterprises to adopt AI, AI must be robust, accurate, consistent, explainable, fair, accountable, continuously learning, transparent, and secure. And a quick way to remember that is using this mnemonic that I have coined called race your facts. And each letter stands for the things that I've just mentioned. So keep these three things in mind as I take you through the details of the talk. AI is everywhere in our day-to-day lives, right? From the phones that we use to the personal digital assistants in our homes, like with Google Home or Alexa, or in our cars with so much of AI in it these days, including the upcoming, at some point, self-driving cars. Other personal digital assistants like watches, and in entertainment with a lot of content and media being available as recommender systems, as our personal assistants in our homes like Roomba, the vacuum cleaner, or various other devices in and around, including the toys that some of our children use in their day-to-day lives that has AI and that can be trained and improved over time. So it's there everywhere, but this is consumer AI. Not to say that enterprises have to work behind the scenes to make this available to consumers, but this is consumer AI. And I'll tell you the difference in a little bit. When I talk about enterprise AI, I'm talking about the following kind of things. These are things like automating, say, processes, such as reading a receipt that you get in a restaurant, and automatically with optical character recognition, take that receipt and digitize it. Or when you call a call center, these days you're able to either get a chatbot talking to you with a voice assistant, or with a chat text-based thing, or doctor's assistants, where doctors are able to leverage AI to help them diagnose and treat patients' problems more effectively, or legal assistants, where AI is able to read large numbers of legal documents and help prepare for arguments in cases, or in social media monitoring, where AI is being applied to better understand consumers' interests and their preferences and personalize things for them, or in retail, where retailers are starting to offer more personalized recommendations to shoppers in store or online. Um, and so on, right? It could be even facial recognition that you start seeing at the airports, and decision support systems like in financial services and such, or in colleges, where things are being used for screening, for credit approval, and for college application screening, and those sort of things. So these are all many different kinds of applications of AI that companies are starting to use. And I'll tell you why this is significantly different from the consumer AI. But first, let's take a look at what kind of building blocks are required to enable the kind of applications, AI applications that I talked about, both in consumer and in enterprise AI. At some foundational level, we need to be able to understand and be able to interact with humans. And for that, we need to be able to understand the language of the humans. So that is the natural language understanding, right? It involves getting down to the specifics of what are the nouns, what are the verbs, what are the entities, relations, what are the relationship between those words, what are some of the keywords that are being expressed, and what are some of the sentiments being expressed, and those sort of things. Then there is speech, right? Being able to understand speech with all different kinds of accents and translate that into text, and the vice versa, text to speech, image recognition, and understanding language at a deeper level, including understanding the tone, communication tones, the emotions, the sentiments, the personality traits of the individuals, and those sort of things. So there are, and the ability to carry on this conversation between people. So there are a set of building blocks that of AI building blocks that are needed in order to build the kind of AI applications that I talked about, both in consumer and enterprise AI. So I'll just kind of set the stage and a little bit of background before I argue about why enterprise AI is different and what it means. Building upon those building blocks, and to build those building blocks themselves, we need, what does it mean? Let's start to unravel that part of AI, right? AI services are the building blocks that we talked about. They need to be taught, right? They need to learn how to make predictions. AI is all about either prediction, optimization, right? So in order to make predictions, the system needs to be able to learn. And to learn, we need to be able to give it some examples. And there are supervised and unsupervised types of learning. But typically, it's about providing labeled data. For example, you give a set of pictures of cats and dogs and label them as cats and dogs separately, feed in, and it learns the contours, the patterns, and is able to start making predictions based on all the examples that it sees, right? So if not all AI services, majority of them tend to be machine learned. And for that machine learning algorithms, this kind of training is required, where data is the fuel and algorithm is the engine. Let's now look at how does one go about building an AI model? And again, I'm just kind of setting the stage still. I haven't gotten to the meat of the arguments that I wanted to make yet. This is the background context on what it takes behind the scenes to build an AI model. And then we'll slowly elevate this and start to apply this in the context of specific enterprise applications that we talked about. So an AI model lifecycle typically looks like the one in the middle. First, you start with collecting data, preparing it. That is, take the pictures of cats and dogs, for example, and label it. Prepare the features, decide on the training algorithms, what kind of algorithms you want to use, what is the training approach, prepare the data and train the model, figure out the right parameters for the model by running multiple experiments and do a model, select the right kind of model, test it on a bunch of data sets, make sure that it's able to classify cats and dogs correctly and measure its accuracy. And when it's satisfactory, you deploy it as either a service that's available on cloud or on premise for clients. And you start observing how well it does it makes its predictions, and you have to continuously keep on repeating this cycle so that the model continuously learns. Each one of these things, the data collection, feature preparation, model training, testing, and so on, each one of them has a huge set of activities on their own, and each one of them have their own life cycles. And there is a need for a lot of AI scope to apply AI in each one of those stages in itself. So just let's take, for example, data collection and preparation. How do you acquire the kind of data that's needed in order to train AI systems? How do you make sure that it's not biased? How do you make sure that it's representative? How do you automatically clean it and sample the right kind of data that you need? And what kind of analytics do we need to measure the distributions of different kinds of class labels and all those kind of things? So each one of these things is a process, and it has a cycle of its own. And there is a lot of AI algorithms that get applied to prepare data, to prepare features themselves, and so on and so forth, and to automatically train and retrain the models with incremental data and so on. So this is a complex web of multiple cycles, and I'll give you with specific examples as we go along. But keep in mind that we're starting to build the case that in order to build AI models, a bunch of stuff like this needs to happen behind the scenes, and these activities then start to have an impact on the decisions, the business outcomes, in terms of the accuracy, in terms of how consistent they are, in terms of how fair their predictions are. And those are more higher order sort of implications on AI models, that one has implications on business activities that these AI models have, that enterprises care about. And that's what we are talking about today. So let's take this example to illustrate why enterprise data is complex. So on the left-hand side is a doctor's note, and the notes that doctor has taken on a patient. This is, the doctor has actually spoken into a device that translated the speech, that recognized the speech and translated that and transcribed it into the following text on the left-hand side. I won't read it, but you can see that the doctor is talking about a particular patient who is having certain problems. And as you can expect, there are several medical terms that the doctor has spoken, like things like meloxicam, that she's having a problem in her lower sternum, that's the part of the body in the lower back where she has a problem. And in terms of the protein levels, like elevated troponin, and she seems to likely maybe ruling out the possibility of having acute coronary syndrome, and so on. So those are all specific terms. So in this particular case, watch out for the industry specific vocabulary. In this particular case, healthcare kind of vocabulary. A normal speech to text model that is trained with human language that you take either, that's news readers have read, or general chat conversations among people. If we take that data, transcribe it, feed it in as training data and train those speech to text models, they're not going to be able to catch this type of vocabulary because they haven't seen it. So they don't know how to really translate from meloxicam that human speaks into this particular word. It thinks that it's a word that it hasn't seen. Therefore, it either will get the spelling wrong, or that it will just not understand the the specific terms very well. Look at the one on the right hand side, which is another example. It's a corporate contract. There are a lot of terms like seller shall do this, buyer shall do this. There are obligations being talked about and the conditions of closing the house and this closing a particular kind of deal and so on. Such, there's a lot of things that talk about who owes what to whom and when, and these kind of things are all, again, very specific kind of vocabulary. And if you want to really automate reading and understanding the who owes what to whom by when type of things, and be able to track the enforcement of the contract and those sort of things using AI, we need to be able to get a deeper understanding and be able to understand this language of the contract. On the left hand side, the language of the health domain. And that is the complexity. That's one of the reasons why enterprise data is complex. Every industry has its own set of vocabulary and its own set of nuances that AI needs to take into account. It's not only that you need to train the AI models to be good at understanding human language, because in the end, these systems are interacting with humans. So it needs to be able to understand the accents, the language, the vocabulary, and all of these parameters and the intent that's being expressed and such. But on top of it, it needs to understand the industry vocabulary and domain. And that is what is the complexity. That's one of the complexities. But let's look at the other ones. Enterprise data is not clean. It's very complex. It comes in different formats, shapes, and sizes. It can be in text, tables, figures, diagrams, PDFs, log files, spreadsheets, this, that, XMLs, JSONs, in all kinds of formats and all kinds of structures, varying from structured to semi-structured to unstructured. And in fact, only 20% of the enterprise data is structured and 80% of it is in this unstructured data, which is very hard to process and to make sense of. Data privacy restrictions make it very difficult to leverage, crowd workers, that is, crowd workers on platforms such as Amazon Mechanical Turk or say Figure 8 and those kind of platforms, because the data cannot leave the enterprise. In the case of building consumer AI, if you want to have, road directions, stop signs and such be recognized, you can take those pictures and just give it to crowd workers and ask them to label it, and you would get large amounts of labeled data very quickly in a short period of time, and you can use that to train your systems. Similarly, you can take hundreds of pictures and thousands of pictures of cats and dogs and ask people to label. You can do that. But in the case of an enterprise, those corporate contracts are very confidential. You can't take it outside of your enterprise. And so that starts to add to complexity. And I talked about all the specific vocabulary of terms and such that needs to be taught for each industry. And on top of it, each company has its own lingo that needs to be taught. And subject matter experts often are not programmers, so they need easy to use tools to label all of these complex enterprise data. So there are lots of these additional complexities. So now, keeping all of that in the background, let's talk about what it takes to make AI work for enterprises. So we talked about the problems and the complexity, but we need solutions, right? So before I go into the next section of the talk, I just want to make sure you're able to hear me. Can Parikshit,
Yes, absolutely, ma'am. Everything's going brilliant. We're getting some questions also, and we'll keep them for you for the end.
Okay, I'm not watching them, so I'm just going to focus on going through the rest of the talk. Okay, so I talked about, now let's talk about the solutions. How do we make AI work for enterprises? So I talked about this mnemonic, raise your facts. I won't go through all of them at the same level of depth because of lack of time. I'll mention all of them. I'll give a quick view into them. I'll cover one or two of them a little bit more in depth than the others. But I mentioned what these things are, and I'm not ordering them in the specific one because I'll go in the order that I'm going to cover. But R is for robustness, A is for accuracy, C is for consistency, E is for explainability, that's race, and facts is fairness, accountability, continuous learning, and security, right? So these are all things enterprises got to be able to trust the AI models. Like for example, when you build a chatbot, the chatbot system needs to be able to understand the intent, and it needs to do what it needs to do. The prediction needs to be highly accurate. It needs to be continuously improving. Um, and the overall AI solution that you build has to be secure. It has to it has to adhere to the privacy and security and compliance standards of the enterprise. And it can't be making predictions unfairly against certain sections of society. It can't be denying loans to certain segments of populations just because they belong to a particular race or a particular age or gender, right? And it can't be a black box system where it just makes a prediction and says the answer is 42. And you will go, why? Well, because I say so. That's not good enough. Or that you are denied your college application, you, and you are denied a loan because I say so, and my answer is 42. Go figure, right? Who will trust it? And there are industries where there is actually not only auditability and accountability requirements, but that they'll be audited, and they have to show exactly what parameters it took, what features it took, and why did it make the prediction. So they have to be transparent and explainable. So there are many of these concerns that you may or may not need to have at the same level for consumer AI. Yeah, when a particular system gave you a movie recommendation, if it's a bad recommendation, you just ignore it and move on. It's not a life-threatening thing, or it's not your like in the case of a healthcare AI, or it's not going to affect your well-being or your job, like in the case of a loan approval AI. um, uh, and it's not like you're and it could be your banking a bank account that's at stake. So it's got to be secure. So there are all of these concerns that have to be um, considered, and enterprises have to pay extra attention to. So let's take a quick look at some of these things. Accuracy, what do we mean? How do you measure the goodness of an AI model? First, let's look at that. When we say accuracy, we are really talking about any of these metrics or a combination of these metrics, and depending on what is the AI model and how one measures it. It's the precision, it's the recall, it's the F measure, it's the accuracy itself, the mean absolute error. In the case of speech, it's the word error rate, how many words did it get right, how many sentences did it get right, and so on. I would have to leave it at this in the interest of time. I don't have time to explain, the details of precision recall, but basically these are metrics for measuring the goodness of predictions, right? How many predictions did it get right of all the predictions it made, and of all the things that are there in the overall space, how many of them did it actually predict, pull. So these are all different metrics that come from several years of fine-tuning these measurement metrics. So I hope that gives at least some background. So for an enterprise AI to be accurate, AI must not only understand the language of the humans, but also the language of the enterprise. So we talked about this particular example of doctor taking notes, right? So let's look at what it means to be accurate. I'm showing here an example of this audio file, right? That a doctor has spoken into the dictation system, which transcribed it into the following text on the left-hand side. And our speech-to-text recognition system, when we put this audio file, came up with this transcription. it made a few mistakes. The ones that are highlighted in red are the mistakes that it made. Meloxicam, it got it right, but instead of lower sternum, it got it as lower stardom. Instead of elevated troponin, it said elevated proponent. Instead of acute coronary syndrome, somehow it thought it was a good con R syndrome. That does not even make sense grammatically. History of this ulcerative colitis has gotten transcribed as a full sort of colitis. So it made a few mistakes. The rest of them it got right, but it made a few mistakes. That's because it has not been exposed to the health domain. We purposefully actually chose the model of speech that has seen only regular human language, the general conversation language and news article day language where newsreaders read news that we have trained it on and so on. Now, on the right-hand side is when after we trained the speech model with a little bit of vocabulary of healthcare domain. All we did was take some text data and taught it by retraining the speech model. And it quickly figured out and fixed the model. And all of the mistakes that you saw on the right-hand side now got eliminated. So how did this happen? So why am I talking about this in the context of accuracy? I'm starting to give some specific actionable suggestions on how to improve the accuracy of models. When we try to solve an AI model that is so broad, the broad AI is so hard because it can be anything under the sun, any domain, any industry, for any company, for any customer, with somebody who is speaking with any accent from any part of the world in any language. That's what we're talking about as broad AI. It's a very hard problem. Even humans actually don't always understand each other's accents and each other's intent, right? There is sarcasm, there is, there is nuances, innuendos, and this and that. So broad AI is still work in progress. Not to say that we won't get there one day, but while we're trying to solve that problem, how do we actually make it practical for specific companies, specific industries? How to make it accurate enough for it to be useful? That's the key point, right? In accuracy, accurate enough that I can satisfactorily deploy it, it's like a chatbot in my environment, and say, I can trust this chatbot AI system that I have deployed for it to good 90% of the time answer the questions for which it's been trained to answer. And I don't have to forward that call to a human customer support representative again, because my whole purpose of deploying a chatbot there is to, for most frequently asked questions, to be able to, for that chatbot to pick up those things and answer customers' questions, so I can use my customer service representatives for more complex questions, right? So if that is your intent, it's got to be accurate enough. Obviously, if the chatbot is so good at answering any question by looking at reading all of the enterprise manuals and is able to understand all accents, intents, that's great. That's the broad AI. That's like a Turing machine solving AI. We all want that, but we're not there yet. So a practical way to do this is to narrow the domain. That is, deploy specific AI systems that solve specific problems. Like, for example, a chatbot that's really good at answering customer support problems in company X for specific kind of questions, such as, password reset for your bank account, or what are my outstanding bills, when is my next payment due, for those kind of questions. Let's say very well defined domain, and you can, if you in that particular industry, then you start to narrow the problem, right? So from being a building, you can start with a base model, like in the case of the speech one that I talked about, where it's learned it with a human language speech model. That's the base model, but it made some mistakes when we brought it to the healthcare domain. However, when we took healthcare domain data and further retrained it specifically for that domain, it starts to get better and better. And you specifically use it for that particular domain after that point, and don't expect it to solve everybody's problems in the entire world. So the point is that as you narrow the domain, so then if you look at the graph, the amount of training data that you need and is plotted on precision, which is one of the accuracy metrics. The more the training data, the better the accuracy is. However, more training data takes more time to acquire. More training data is more expensive, cumbersome, and it's often not available in the quantities within the amount of time and budgets that you have. So you start with what you have, but then you narrow the domain. So what happens, these are called learning curves. These learning curves, you can start to narrow them, and you can start to accelerate the accuracy curve. With even with smaller amounts of data, you can achieve higher amounts of accuracy because you're now narrowing the problem. So that's the key idea. So that's what we ended up doing when I talked about in this previous chart, general purpose versus customized speech. Instead of trying to be good at everything for everybody, we try to we narrowed it to, customer. Start with the base model, but then specific retraining at the industry level for specific context will start to get you better results. So the strategy for improving accuracies of AI models so that they can be practical and good enough and useful for enterprises are the following: build broad-based base models with as good a coverage as possible, then narrow the domain to accelerate the learning, build AI models so that they can be customized by consumers of AI models. So for example, you can think that you have customized it for the healthcare domain all you want, but when you go deploy it in a particular hospital, you will still be in for surprises because of the specific uh, accents or specific terminology that they use and such. So these AI models have to be given that retraining APIs, if you will, the application program interfaces, so that you bring in some additional data at any point in time once it's already available in an environment, and it starts to further improve on a regular basis. Not that it just sits with the first iteration of the models that a company has built and given to this hospital, and they just have to use that. No, it will make mistakes, and users will provide corrections, and it should be able to take that and improve. So that leads me to continuous learning. So it's highly accurate. In order to get there, I gave you some specifics on how to narrow the domain so you can accelerate your learning on with even smaller amounts of data. But now the models can't be stale. They have to continuously keep learning. So it's like this, right? When we were kids, we all went through this process of learning to ride a bike. And on the first day that we got our bike, we were not able to run it. We were not able to balance. We fell many times in the coming several days and weeks. And at some point, we all got the hang of it, and we can ride a bike. And that's a skill that once you acquire, you have it. But during that process of learning, you fall many times. So AI on day one may or may not be able to perform at the level that you may want, or may not be able to understand everything that you're looking for. Um, it's going to have to learn over a period of time. So the best way, so let's say a kid makes a mistake in a math test. The way to do it is look at the mistake and understand what concept the kid did not understand very well, and devise many examples, and teach the concept once more, twice more, how many other times it takes, and have the child do many practice problems on that particular concept, right? If it is, let's say, factors or exponentials, long divisions, whatever that particular thing is, you give more examples and more sample problems to solve. And once that concept sinks in, the student gets better at it. When I talk about continuous learning, it's the same thing, that it's not just that you need to throw more data at it and expect it to improve automatically. If the kid had a problem in exponents in math, if you're giving more practice problems in long divisions or factors, that may or may not help the kid at all to learn to learn the skill of actually getting the exponents right. So part of the idea of continuous learning, the trick here is to really understand where the system makes mistakes and do a very diligent error analysis, exactly like how we look at kids' test paper and understand the concept gaps and teach the kid in that particular area. Exactly the same thing needs to happen with AI. So from a methodology perspective, a prescriptive guidance that I can give is that when we supply input data to an AI model, let's say it made a prediction, and that prediction is either correct or incorrect. If it is correct, it's fine. If it is incorrect, we want a human to look at it and tell us where the model made mistakes initially, because it's the human in the loop process. Unless somebody who knows what's right, what's wrong prediction is able to look at it and give us that feedback, we won't know. But over time, we can build AI models to also classify these errors automatically, and also make predictions on the predictions that AI model makes to say, hey, it's likely going to get wrong or right. When a cricket match happens, you can say, based on the history, I can say that when, India and Australia play, India has this much chance of winning and Australia has this much chance of winning. And you say, especially when the weather conditions are this way, and when, who wins the toss, and when it's in that stadium, and, the audience is like this, all kinds of factors are taken into account and people build models, right? So same kind of an approach, you start to look at, you can build models, these are called observer models as we call it, that can make predictions on that eventually. But let's say initially a subject matter expert is making those predictions, correct or incorrect, and those ones where there are errors, you prioritize them and say, okay, now I'm going to take the data that came in where it made mistakes, I'm going to filter it, prepare it, I'm going to label that data, and I'm going to specifically retrain the model in those areas, and I'm going to build a new model and bring it back. So this is the continuous improvement life cycle, and it takes a lot of AI to build all of this life cycle to improve an AI model. So it's AI for AI, AI for data, data for AI. So there is, all kinds of recursive and meta loops going on to build AI. So here is a specific example where we had a sentiment analysis model that we built, and we were looking at analyzing how well our sentiment model was doing. If we had a text that was short text or long text or medium text, are we making any mistakes? So we took one dimension and looked at, if we had about 4 to 8 words in the sentence, our accuracy was 71%, but it started to go down, and it was kind of very poor when we had long text with 36 to 144. That means when you had a paragraph, basically, with lots of stuff going on back and forth and such, and we were not doing a good job at the time predicting the sentiment of a paragraph. If it was a single sentence saying, I really liked the food in that restaurant, or the service was not good, those kind of things, the sentiment was able to get it right for the most part. So here is an error analysis, right? We specifically figured out a dimension, which is the length of the text as the dimension, and identified the weakness. The weakness is that as when there is a long piece of text, we're not doing well. So that's the error analysis we did, right? Then we got to figure out how to improve the model. So then what we said is, okay, maybe we ought to design another sentiment model that's really good at just processing long text. And at runtime, when the text, the number of sentences, the number of words is found to be more than certain cutoff limit, we pass it to the other model, and that other model's accuracy is good. So that's an example of an error analysis. And for continuous learning, we are constantly taking this additional data and improving it, and multiple iterations. So this is an example of how there is no magic in here, as in you build a model, you observe what it does, you collect all the data, you look at where it makes mistakes, you go through it painstakingly, and where there are gaps, that's where you teach it and make it continuously improve within the environment. And that's the key. Users have to give feedback, and then it starts to get better and better over time. So that's the strategy. Let's look at fairness. Again, I'll probably cover just few more in 5-7 more minutes. I'll conclude the talk to leave enough time for questions. Fairness is a very hot topic, the ethics around AI, the biases and such. In 2018, there was an article in New York Times that triggered an uproar that was based on a paper that was written which is listed at the bottom of the slide here. Basically, the gist of it was that somebody went and did some testing on image recognition AI models out there being offered by all big vendors like Google, Microsoft, IBM, and so on, and fed in a bunch of photographs. These are the photographs of parliamentarians from Senegal country, and it did a very poor job of all of the systems of recognizing African women's faces. Um, so the uproar was raised saying that these are all biased AI models. They're racially biased and such. So what happened behind the scenes after investigations? It so turns out that there was no intentional bias built into these models, but what happened over time was that uh, all these AI models, basically they got hold of whatever photographs they could get a hold of from the standard repositories like ImageNet and such, and trained their models. And those ImageNet and such repositories, they happen to have been crowdsourced, and it's just that there was very poor representation of African women's photographs, um, and that lack of enough representation in the input training data reflected in the accuracy of the model's predictions. So what this kind of really brings out is that a lot of times there could be biases, some that are unintended, undesired, not only undesired but unintended. They could seep in data during day training, or in the selection of features, or the choice of algorithms that you make in the models. Any number of things could contribute to it. And I'll just talk about one example of the data bias and what you can do. The main problem is that when those image recognition systems were created, nobody set any specific goal to them. The goal was, it appeared that let's recognize human faces. But then, humans are very diverse creatures. We have all kinds of skin colors, we have all kinds of age groups, genders, and different ways of dressing, and all of that. So if it's a broad AI problem, let's recognize human faces. It's a very broad problem. If that was the case, then one should have really sat down and looked at, okay, how many races are there, what are the various continents, what are the various countries, how many kinds of people. Let's make sure we have enough representation of all of them. But that level of thinking hadn't gone into this thing. So that's why I say, when you don't know where you're going, every road will get you there, right? So you got to have very specific goal and clarity of what are you building the AI model for. Let's say, if I'm building an AI model for recognizing rusty bolts, right? You specifically set some test data sets and say, here is the list of all of the rusty bolts kind of things that I would like you to recognize, or at least it's a good representation of the set. Create your goal and create your test data set ahead of time as you're collecting training data, and say, this is what it should do very well on. Everything else is a plus. And what I don't know. So I better declare my biases. So one of the things that I always advocate, and I wrote articles about, is this: you have to set clear goals and start with test cases. As with any good software engineering practices, you write with your test cases first before you write your code. Declare your biases. If you have trained your models with a specific amount of a different kind of a specific kind of data, just make it very clear. Like, for example, when you buy a nutrition bar, it tells you, right, how many calories does it have, how many carbs does it have, how much fat, how much sugars, and this and that. So you know exactly what you're eating, and you can make a decision on whether it's something that you want to consume or not. But it's you have given the details of what it has. Similarly, an AI model should say, I have been trained with this kind of data but I have not been trained with, enough of African women's faces. So then people will know, okay, well, it is what it is. Maybe they didn't have enough data. So if I want to, it to recognize African women's faces, maybe that's not what the AI model that I'll use, or that, I'll put that requirement in even for my company, and make that particular AI model be good at it. Make sure I test it before I deploy it, right? So that's one way to get rid of at least mitigate the unwarranted biases seeping into the AI model. So I'll really gloss over some of these other things in the interest of time. AI models need to be explainable. Yes. There are some philosophical debates we can have on whether, how transparent should it be, and does every model need to be fully explainable and transparent? Explainable to some extent, I would say yes, most of them should be explainable. But in some industries, there is a lot more scrutiny, like in the case of loan application uh, processing and such, because it affects your finances. Whereas in some other applications, it may not be that critical. When you're doing, for example, social media monitoring, broad-based sentiment analysis on people's interests on specific product, even if you get some predictions wrong, it's okay. You're doing analysis at a mass level, so it doesn't impact anybody's well-being, or finances, their health, those kind of things. So the level of transparency required varies depending on the domain that you are in. In some cases it might be okay, and I put this picture on the right hand side. It's kind of a provocative one just for discussion purposes. When you go to a doctor, you don't particularly ask the doctor, how does this particular crocin medicine work? How does it break down into its corresponding compounds? How does it react with my you know gut acids? You don't ask for explainability at that level, right? You just trust the doctor to give you the medicine that works for your body, given all the other conditions you have, and you take it and you believe in it, and most of the time it works. So I know it's a provocative statement, but I just wanted to kind of contrast, saying the level of transparency and explainability that you need may differ depending on the specific use case and domain. So you got to keep that in mind, and not to over engineer it, and not worry about it if it's not that critical. Anyway, understand your options and trade-offs. Different algorithms will be more either amenable or not to transparency. So you may want to keep that in mind as you build it. And sometimes you may use rule-based approaches. It's not always the machine learning, deep learning, or statistical AI that's really needed. Rule-based approaches tend to be more transparent, although could be difficult to manage over time if you have too many of them. Okay, consistency. This is my interesting, famous, my interesting, it's a quote from Sherlock Holmes, a book that I have read and reread many times, several books of Arthur Conan Doyle. But among the first ones, I believe it says, Sherlock Holmes says, there comes a time when every addition of knowledge you forget, for every addition of knowledge, you forget something that you knew before. So when you build statistical AI models, let's say the model made a mistake in prediction. You teach it oh yeah, this is a wrong prediction. The right thing is this. You put it in and you pray that it gets taken into account. There is no guarantee, because it's statistics. If you just give one sample, it may or may not make it to the next iteration. So in trying to fix something, you may actually make the system forget something else, or make mistakes in another area where it was actually making better predictions before. In statistical AI, there are no guarantees, but in businesses and enterprises, sometimes users get very frustrated when they gave you feedback on something that this prediction is wrong, and the system continues to make the same prediction mistake again, or worse, even worse, in areas where it was doing fine. When it stops making predictions correctly, people lose trust in that AI system, right? So that consistently learning is very important, as in you cannot go 2 steps forward, 1 step backward. And that's a very difficult thing in statistical AI. And this is, again, another challenge. So you got to really kind of pick your domain, pick pick what are the requirements, what is needed here, how much transparency, how much consistency. Based on that, you got to pick different algorithms or different even AI models to start with and such. So that's the summary. I will skip on the accountability and robustness. There are a bunch of things in there. Let me summarize it. Um, to make AI work for enterprises, these things need to be accurate. They need to learn continuously, like in the case of a kid falling off a bicycle or a student making mistake in a math problem, as I talked about. They need to be fair. And for that, I talked about setting goals first and starting with the test cases and declaring your biases. They need to be transparent, and I talked about how much transparency is needed. Be careful, observe that, and based on that, make selections. They need to be consistent. They need to be improving, and not just going 2 steps forward, 1 step backward. I didn't talk much about accountability, robustness, but I'll just summarize it and say, if you are not careful, you could be pulling in data in every iteration, and really making that AI model do something else than what you originally intended to, and as in it starts to drift. So you have to really monitor and be careful in what data you feed in, so it doesn't drift, and it's everything is observable, and there is a lineage, and you can be ready for any kind of audit. Robustness is about, people can confuse the system in any which way. What might look like a washing machine might look like a refrigerator. What might look like that could also be made to look like a dishwasher, depending on the angle of the photo. So the system could make mistakes, and people can use that to make good guys, bad guys, good guys. All kinds of things could happen, right? So AI models need to be really robust. Just um, there are different techniques and approaches for making AI models and training data um, more robust towards this kind of adversarial manipulations. And that's a whole field in itself. We can talk about it some other day. So let me summarize the key takeaways. I told you at the beginning that enterprise AI is more complex than consumer AI, and I gave you specific examples of the industry, the language of the industry, language of the enterprise, and I talked about um, it's not just the language of the humans, but the language of the industry that it needs to learn. And I gave you very specific set of attributes that AI should have, such as these ones that are on the screen, and a quick mnemonic to remember them. That is, raise your facts. Each letter stood for something like robustness, accuracy, consistency, and so on. And yeah, so those are the 3 things that I wanted to cover today. In the end, it's really about narrowing the problem for specific domains, specific use cases, and solving the narrow AI problem. And I would say there is no shame in solving the narrow AI problem and making it do what we need it to do for practical purposes. And someday we'll get there for solving the broader AI problem, hopefully. So with that, let me pause. This talk was about how to make AI work for enterprises. Hopefully this was informative and useful. Let's open it up for any questions at this point.
Thank you so much, ma'am. That was brilliant. It was also very practical oriented. We've got a whole bunch of questions. I'll try and see as many as we can take. We've got one pretty interesting one from our next presenter, actually, Keber Melli. He says, could you please expand on how to structure a team that delivers enterprise AI and ML? This is likely dependent on a specific task, but any generic pattern that you can recommend?
How to structure a team?
Like an AI ML based solution, creating team.
Yeah, very good question. It's so first of all, as with any software engineering, good software engineering principles, you have to have specific team members that are designated with specific roles, and we have to have clarity on those roles. Not only the coders, the deployers, the service builders, the more traditional ones, but in the case of AI, there are data scientists or machine learning engineers who know how to build AI models, and there are data managers who understand the issues around acquiring the data, the legal and I would say, budget friendly ways of acquiring data, preparing the data, governing the data, and making sure that it's adhering to security, privacy, and compliance types of things. So there are new roles in the case of an AI. The way we have structured at IBM when we are building these models is we have data scientists working very closely with the the AI service developers who are packaging this, who do all the the continuous improvement, continuous deployment, the CI/CD work. There are testers who are also data scientists because they need to understand, be able to evaluate these AI models, the goodness of AI models. It's not only testing it for deployment verification tests and the unit tests and of the code itself, but really the quality of the AI models, who set aside test data sets and measure the precision, accuracy, all these things, and they tabulate it, and they manage the lineage of the models, one model version versus the other model version. How do we compare the goodness as we improve them or retrain them and such. So we have new, and the data was a huge area. 80% of time gets spent in actually preparing data and getting it ready to train AI models. Then I would say one other thing that I did not highlight that much today, but really all these things that I talked about, the continuous learning, ensuring that the data is fair and it's transparent. We need a platform for doing that, because not every AI team that builds AI-infused applications need to spend their time in reinventing the wheel of making sure that the platform level things like that I need to be able to save the model's predictions. I need to be able to reuse that to retrain the models. How do you retrain the models? How do you do model selections? How do you do um, the retraining and simulations and all of that? We need an AI platform for that. I call that an AI CI/CD, similar to the service CI/CD. And that kind of platform is needed. There are some out there from different companies. We have one within IBM, like IBM Studio, which has Watson machine learning and open scale, both at the build time and run time. So we use those kind of platforms for building AI models. So overall, I would say structuring a team, one has to put a lot of thought and carefully design that to account for the new roles that are required for building AI models, such as data scientists, data managers, data preparers, and in fact even crowd workers or the people who label data also become an integral part of the team. Like the crowd workers, if the data can go outside, or you bring SMEs to label the data. So there are a lot of these roles that are not part of traditional software engineering organizations that now need to be added to build AI models.
Right. I think we'll also have to keep focusing on the acronym that you've given us, because that's a guiding, thing for us. One other question I'll take right now. You mentioned something about every industry having its own, wordings, like in particular for NLP kind of situations. What about language where things like interpretation is important? So one thing is meaning, right? And what about things I'm specifically referring to the widely publicized Watson dealing with the legal issues?
Yeah. So language, when I say language of the enterprise, that's what it is. The intent is, when I talk to a chatbot, for example, I say, my phone is not resetting, my password is not working. There is an intent that I'm communicating, and that intent needs to be translated into, that intent is then guides the specific action that needs to be taken. That intent becomes the category, either in an enterprise problem resolution document, or in the dialogue tree that you have. And that intent is what we are after, right, when we are interacting with an AI system. And that can come, and there is a lot of natural language processing that needs to happen to understand that. First of all, things like what's an action, what's a verb, it's not working, what's not working, that what is not working is a noun, and the relationship between things. But in the contract domain, like one of the examples that I have given, it elevates it to a whole different level, right? To who owes what to whom, that there are binding things. By certain date, certain thing must be done by the purchaser. By certain date, these 5 things need to be submitted by the purchaser, or the seller must abide by this. Being able to pull those things, it requires training. First of all, it requires understanding PDF documents and being able to go, or tables, or different formats and tables of contents, and going and understanding, pulling that stuff out from all of those fields, and understanding at a semantic level, right? Semantic with role labeling and all that, understanding this is the intent, this is the entity, the doer, the person who is on the receiving end, on the giving end. All of that language understanding, you got to build it into domains. And for example, purchase order domain, or procurement domain, and so on. So it's that is what makes enterprise AI complex, and that is where the industry specification or the use case specification needs to come in, where you build these semantic understanding models for specific domains. And in the case of Watson, we ended up building it for
legal
legal domain. Legal and compliance domain.
Got it. All right, ma'am. Thank you so much. We have to stop here, even though there's a whole barrage of questions. If you are okay with it, I'll shoot these out to you on an email, and whatever you can comfortably respond to, I'll be gladly sharing it with our entire team and everyone else out there. If you're comfortable with it. Also, any chance we can get your slides, because a couple of your questions are answered with your slides. So if you are comfortable, and if it's possible, and if you could share the slides, that'll be brilliant. That's obviously up to you.
Yeah,
right?
Sure. We can take this offline, Parikshit,
Sure.
and,
right.
and take chat.
Thank you so much.
Thank you. Thanks once again for having me for the Data Science Congress, and have a good rest of the conference, all of you. Thanks for your attendance.
Thank you, Rama. Thank you so much for such a wonderful session. Very relevant session for enterprise AI and scaling up. Thank you so much.
My pleasure. Have a good rest of the day, everybody. And
you too. Bye-bye.
have a good conference. Bye now.